Hello, everybody. Thanks for having me on today. Just a warning for folks. I am in a boat down in San Diego, California, and occasionally bandwidth gets a little iffy. So if it hangs up for a second, just give it a beat and I should be right back. Thank you all for tuning in. Yes, it was a great experience. I had been thinking about going up to this polar research station for probably 5 years, invited by the founder of it, Dr. Pascal Lee, who's a planetary scientist up at Ames Research Center and the SETI Institute. It's a little costly to get up there, so it took me a while to make my decision, but I really wanted to do it, and I wanted to go on the right kind of analog mission. So there's a lot of different kinds of analog missions. This is co-sponsored, the only one of its type that's co-sponsored by NASA. They pay for about half of it, and then the rest of it's by private donations and participants. So there's two stations on Devon Island. There's the Haughton-Mars project, which is the one I went to, which is the larger of the two. And then there's one called the Flashline Station that the Mars Society runs. That's a single unit. We have about 7 buildings at Haughton. They're both near the Haughton Impact Crater, and I'll show that in a few minutes. The important distinction, though, is what the Mars Society tries to do is a procedural analog. So you go up to the station. When you leave, you put on a prototype spacesuit, or a facsimile spacesuit is a better word, and you go into a faux airlock and you do a depressure cycle simulated, and then you have a 5 to 15 minute radio delay and so on. So it's really more experiential. They don't generate a lot of data, but it does give people a taste of what it would be to like up there, like up there. In our case, we didn't do any of that. There is one suit that Hamilton Sunstrand sent up a few years ago that's used for specific research projects that I'll show you. But we just walk outside in a lot of jackets and fleece pants and that kind of thing, because what we're up there to do really is test exploration strategies and technological approaches to specific projects in either exploration, transport, sample gathering, that kind of thing. So without any further ado, here's Devon Island. This is the northern hemisphere. Obviously, the pole would be a couple inches up above the blue Devon Island tag there. It's the largest uninhabited island on Earth. It's a polar desert. So while when you look at it from the air, it looks snowy. This is a picture taken, I believe, late autumn. When we're there, everything is brown, and they're just little patches of snow and ice, but generally speaking, it looks kind of like the Utah desert, except there are no plants and so forth. So that's where the Haughton Impact Crater is. It's the largest impact feature in the northern hemisphere. It's old. It's about 23 million years old, so it's fairly eroded, and the topography has been changed a lot. But it is geologically very much like you'd see an older crater on Mars once it's endured some weathering, because the weathering patterns are not as dissimilar as you would expect for being on Earth. So here's me 3 weeks before departing, trying to figure out how to put all that stuff into that orange duffel bag and keep it under 50 pounds. I did not succeed. I ended up paying some excess baggage. The problem I had, I was going up there to cover this as a journalist and possibly for a book, and to help in some of the research projects just as an assistant, because I am not a scientist. And the problem is you have to take 2 or 3 of everything, because the environment is so dry and there's so little wet weather, especially during the summer months, that the whole place is just a constant cloud of fine grit. And it's really sharp because it doesn't get water weathering as much as other places. So whether it's a computer or a camera or a lens or your GPS unit or anything else, you are constantly fighting this problem of grit. So I had to take 2 laptops, 3 camera bodies, iPhone, of course, 6 or 7 lenses, and so on and so on. So your load gets pretty heavy. And of course, you've all been through airports. You try and jam everything in your carry-on that you can to avoid having overweight baggage. But I think I was up to about 35 pounds in that carry-on, and I'm an old guy, so that was no fun. We left from San Jose. I drove up to join Pascal, and he and I boarded a plane there. This was the airport at 4 a.m. Isn't that a nice view of an airport? How often do you see that, right? And we got through pretty quick. It's a little more complicated because he brings his dog with him. He's got an Australian cattle dog, which he has registered as a service dog. But the airport people get a little grouchy because he's not a traditional service dog. He's a polar bear alert system, in essence. But it was great having him along. So we sped through that. It takes 4 days to get up there and about 8 to 10 stops, depending on how often they have to land to refuel. So it's a long, long journey. One of our nearest stops to the actual area up by the pole, we were about 15 degrees south of the North Pole, is a city called, or city, a townlet called Iqaluit, which is a native Inuit word. And that's the Inuit alphabet above, which I thought was fascinating. It's extremely, it almost looks like an alien alphabet to me. This is what Iqaluit looks like. This is actually the town just before it, called Arctic Bay. But this is generally what the land up there looks like. It's very barren, it's very dry. There aren't a lot of plants. You do see some moss and lichen in the background there in the hills. Everything's prefab, and the population is primarily Inuit, because a lot of Inuit got resettled by the Canadian government up to these frontier areas if they weren't already there years ago. That's a long, arduous story, but basically it's a primarily Inuit population with Europeans there as well to, run certain businesses and social services and so forth. So we did, 1, 2, 3, I think on the way up it was 8 stops. The last one was called Resolute Bay. It's a town right on the edge of the Northwest Passage. And its primary function, besides supporting, us and the Mars Society up on Devon Island, is to be a monitoring post for the Canadian government and military for the Northwest Passage, because they want dibs on the going through there. So that final leg between Resolute Bay and Devon Island is on a twin otter. So the planes get smaller and smaller and the schedules get looser and looser as you're going. And it took us, I think, a day and a half to get out because you got to wait out the weather. But this is flying over the edge of the Northwest Passage and onto the edge of Devon Island. So you can see there's a little bit of sea ice, but really at this point, we're looking at a very dry, dusty, fairly low-lying topography. And Devon Island smile and thumbs up. That's Pascal being excited about being there. So this is an aerial shot of the area where we are. You can see the HMP research station indicated there with the white arrow. That's the Haughton crater to the right. So we're just over the rim. This is Inuit territory, so we're there by permission of the indigenous government. And the rule is, you make minimal impact. Everything that goes in has to come out. And we'll talk a little bit more about that. This is an overhead view, so you can see the topography around us. So the Haughton-Mars project base camp is indicated by that red Google tag there. Just to the right, you can kind of see a little hill with some stuff on top of it. That's called Fortress Rock. That is a big vertical feature like you'd see in Utah or something. Then off to the right, a little out of frame, is the other station. So the idea when they put these two places up was they wouldn't be visible to each other. So the camp we were in was originally a support and logistics camp for the smaller simulation base over to the right that you can't see. At this point, they're operating independently. This is a high-level picture of the base. So in the center there, you see that building. You can barely make out. It's got little round windows. That's called the core. That's the center of the complex. And then we've got the 5 Quonset hut structures surrounding it. Those are pipes with cloth over them, and a little bit of insulation that doesn't do very much. Then there's that big white flat area, which is a working area. And then off to the left is the greenhouse. They're working, I think, with the University of Arizona on an experiment to see if they could make an autonomous greenhouse that would operate for a year in Martian conditions. That was successful. The road in and out goes out to the airfield. There are almost no roads there because there are no people there. So the only roads, quote unquote, made are just tracks from the ATVs that we use to get around year after year. This is just a ground level view of the same thing a little later in the day. This is a close-up of the center. So the over to the left is that core structure I was talking about. That's just made out of plywood. The initial plan was to connect that to all the outlying tents with tunnels, but between the Arctic wind and just the weathering, They decided not to. There's also an ozone hole up the North Pole, so stuff gets eaten up very quickly by UV. So those buildings don't last as long as you'd like them to. This whole thing was constructed between 1999 and about 2002. You see in the center there, that yellow Humvee, two Humvees were donated by American General, who builds them, to the project to use as simulations of pressurized Mars rovers. Again, mostly for procedural purposes. You're obviously not going to take a high mass object like a diesel driven Humvee up to Mars, but it does give you some sense of how you can proceed. And I'll give you a little more detail on that. And of course, to the left center, that's Pascal with his dog, whose name is Apollo, who likes to stand up on people all the time. This is the team. I'm to the right there, and I'm not really quite that wide. That's wide angle distortion, I swear. Immediately to my right is Rigel Capello. He was with MIT. Next to him is John Barrett. He was also with MIT. The guy immediately to the right of the yellow balloon there was named Jason Suhu. He's an MIT IT guy, and everything's so computerized now, you need an IT person with everything you do. That's Pascal in the center. To his right is Savan Dalal, who was a fourth-year medical student that we had as our safety officer. The young guy in the light blue hat was named Gabriel Dubé, and he's an engineering student in Canada who was our drone pilot, because we were doing a lot of drone work. Then finally, in the far left with the gray beard there is John Scott, who's a very quiet guy that, you know, if you met him, you'd think maybe he sold insurance and just decided to grow a long beard and look like he belonged on a bus stop somewhere. But he actually he's done 32 seasons in the Antarctic as their summer camp runner for meteorite hunting, and 22 seasons up in the Arctic. And when he's not in one of those two places, he and his wife go off and have incredibly difficult and challenging and uncomfortable adventures. So he's a true mountain guy. That's Pascal and the dog. Just wanted to give you a shot of him since he was the person that thought all this up. So really, he willed this base into existence. This was his grad school project that ended up becoming this complex. This has been running ever since by dint of hard work and his intellect. This is where I was staying. This is the medical tent. You see there's not much to it. There is no running water. We have water in 5-gallon casks. We go down to a nearby melt pond and pick up water, which is very clean, so you don't need to purify it or anything. And the electricity is from a small diesel generator that runs about 14 hours a day. Here's the inside before we got completely unpacked and cleaned up. So basically you work in there during the day, and then you clean off those two blue tables to right and left, and that's where you sleep. So, you know, it isn't quite the budget in, but it's close enough. And because I know somebody's wondering, when you have to go to the bathroom, you go into the poo tent, as they colloquially phrase it, and you use the same kind of thing you'd use in a hospital, little toilet with a plastic bag. It's something you want to do very fast when it's 22 degrees outside. The preferred mode of transport up there are ATVs. These are about 12 years old now. They're Kawasaki's. They're investigating getting electric ones and getting something a little more realistic to what you'd end up using on another planet. Obviously, these aren't, but just for practical purposes, this is what we've been using. So they got about 20 of them at any time. There's about 8 of them that are running. Polar bears are a very real risk. The ice cap is melting, of course, the North Pole. So there's a lot fewer ice flows for the seals to pull out on. So polar bears have gotten very hungry, and indeed a lot of them are starving. So unfortunately, we all had to be trained on shotguns. I already knew how, but most of the other guys didn't. And whenever we go anywhere more than about a quarter mile from base, we'd have somebody carrying a shotgun. The last thing you want to do is have to shoot a bear for 2 reasons. One, it's just not a nice thing to do, and 2, you're liable to not hit them. So the first 2 charges are flashbangs, try and scare them, and then after that are slugs. But we never did encounter one, so I counted that as a win. This is the view from camp looking west. What I think was most interesting to me as a photographer, and from the graduate studies I did in perception, was you're looking at a landscape that has no recognizable artifacts at all. So distance was very hard to judge. I thought that rock was about 2 or 3 miles away, that big rock to the center right. Turns out it was just a few hundred yards. It was only about 12 feet tall, but your lateral distance you can kind of gauge, but your distance to and from you along the z-axis is really impossible to ascertain, even after you've been there for a few weeks. You get a better sense, but it's still tough. And after about 4 days, a weird thing happens. Your primitive mind starts to get a little twitchy because you realize I can't gauge these things. And if a tiger jumps out from behind a tree, I'm going to get eaten. Well, we didn't have any tigers, we didn't have any trees, but you still have this very primitive fear. So there's a period of adjustment where you're feeling a little strange about being there and you're spending a lot of time being worried. This is what the landscape looks like in the afternoon. One thing I hadn't expected, I knew we weren't going to see the aurora borealis because it's summer up there, so it's light all the time, and the sun just barely goes below the horizon for about 45 minutes. But what you also get are about 2 hours of sunset and about 2 hours of sunrise, which really makes for some incredible visuals. So this color has not been adjusted at all. That's what the dirt looks like for about 4 to 6 hours a day. So it is very Mars-like, including geologically. That's that fortress rock I told you about that's nearby. Nothing remarkable about it, except it's the only feature like it nearby. This is at high noon, so it gives you an idea of what it looks like during daylight. Again, still very Mars-like, not just the color, but the formations and the type of wear that you see in the soil and the rock features is very Mars-like. So especially if you're doing mobility studies, you really get a good sense of what we're going to be facing up there. And I tell you, whatever machines they send up to Mars had better be well sealed against grit because it gets into everything. I got home and unzipped my duffel bag, and this cloud of red dust about the size and shape of the duffel bag rose out and right into my face. So it's a constant challenge. Here's a close-up of some of the rock features. This whole area was submerged for many, many thousands of years, about 10,000 years ago. So there's a lot of coral reefs in here. Kind of thing we might find in the northern hemisphere of Mars if it turns out there was microbiological activity. In this particular case, because there's a lot of this old broken up coral, everywhere you go, everything is sharp. The grit is sharp, the rocks are sharp, the buttes are sharp. If you sit down somewhere, it's sharp. And I went through my pair of brand new boots in about 2.5 weeks, and they were ready to be thrown away. The weathering is primarily thermal. So you start to get a little crack in a rock, and of course water seeps in, freezes, and that exerts a lot of hydraulic pressure, and the rocks begin to shatter. And that's how you see most of the features made. So one of the results of this is, if you're riding an ATV through a river valley, if you were doing that in the continental United States, you'd normally be going over rounded river rocks and cobbles. Well, there's not that much water running there. And since most of the weathering is this kind of hydraulic fracturing, everything you drive over or walk over is a sharp rock. They're sharp rectangles, sharp cubes, and it really does a number on your spine after a while, among other things. There are no plants except for lichen. So my boot's just in this shot for scale. So this is a little patch of lichen. The only places it grows is where either an insect dies, a bird dies, or a bird defecates. And this little microbiome will spring up just long enough to go through whatever nutrients are there, and then it dies and blows away. So virtually everything else you see is rock and dirt and silt and clay and dust. There's no trees, there's no shrubs, there's no telephone poles, there's nothing, just you in that environment. So here's, I had to put a picture of me in here somewhere. Here's a picture of me getting ready to head out on our first traverse in one of the ATVs. The environment's really tough on machines, as I mentioned. This is a larger ATV we had that is a two-place vehicle with a small truck bed. We were coming back from deploying an experiment that I'll tell you a little bit about later. And I noticed a red light on the dash, and I said, "Hey, Pascal, what's that red light?" And he said, "Oh, no, I've never seen it before." It turned out it was overheating. And so we brought it back, and I have some mechanical background, and John Scott has some mechanical background. So we worked on it for a couple of hours, got most of the way there, but there was a blockage somewhere downstream the cooling system right near the engine. And I mention this because that's the moment that I realized that we're about 1,200 miles and $6,000 away from even bringing in a gasket. or a ball bearing or a new distributor, whatever you need. So if you have a problem like that, you don't have a stockpile of spare parts, you're pretty much done. So here, this thing is going to sit until next year. We could bring an assortment of parts, try and get it fixed. This is one of those 2-hour sunsets I was talking about. It was probably clear in the evening about half to 60% of the time. It was about 50-50 on daytime, whether it was overcast or broken clouds. I decided I want to bring up some entertainment because we didn't have any. So we'd gather around some evenings and watch a movie on my laptop. And I thought, I've got to take up the 1982 version of The Thing because it takes place in Arctic Research Station. As I brought this up for us to watch it, it's fairly grisly. It's very paranoid. And I didn't know that it had actually been banned at the McMurdo Antarctic base because when people spend 6 months of darkness down there, they get paranoid enough without seeing a movie like this. But we watched it anyway and had a good time. And that was the only horror film I brought. In the evenings, when we had downtime, we do science talks. And this is a polar tradition. This goes back to the European so-called heroic age of polar exploration, where you're locked in the evening. Like them, we just had each other to keep ourselves entertained. There's no internet. There's no Twitter, there's no Facebook, there's no streaming television. So it's basically you and your brain and your friends. So one of the things we did was a series of science talks. In this case, this was some first aid training. Savan did about 4 of these, and it was good to know because you never know when you're going to need it up there. Also from the heroic age is the tradition of bringing up a campaign flag, and they had never had one. And Shackleton and Scott and all those European guys, of course, would make their little banners that they'd stick on their sledges or at their base to tell the world that the Europeans had arrived to claim the ice cube. So I found there's one picture on the internet, there's one photo of the campaign flag that Shackleton had from his 1907 expedition down to the South Pole. So I found that, had Tony's brother work up a graphic for me. Thank you, Mike. Thank you, Tony. And had a flag made. So here's Pascal putting it up in the operations tent. And then I thought, I want a campaign flag. I may not be an explorer, but I'm going through a lot of effort to go up there. And I thought, what would be appropriate? So here's my campaign flag, which is eventually selected to go up the pole where it still stands today. And it's a depiction of the Earth with Mars rising in the background and one of H.G. Wells' war machines doing a number on the ground, burning up a bunch of cows or something. So tongue in cheek. So after we'd been there about 4 days, it was time to go on our first traverse. So we got very, very basic training on ATVs, which none of us except Pascal and John had ever ridden. And we took off. I think that day we did about a 40-mile round trip, mostly scenic. We went over the rim of Haughton Crater and then got up to some high overlooks so we could get a sense of what the local geology and topography was like. This is riding along a large melt pond that's there pretty much year round. Of course, ice is over in the winter, but it's wet in the summer, so we can go get water out of there. And a lot of the topography is just rolling hills like this. There are much steeper inclines and much larger rocks, as I mentioned, but this is generally the kind of thing you encounter when you're crossing the terrain. This is the obligatory I'm pointing at something shot, but I actually didn't stage this. This is Pascal telling the guys what the crater topography was all about and meant. And oh, by the way, there's the Mars Society's little station standing around alone in the background. Nobody's been there for about 5 or 6 years. Pascal's base, nobody had been there for about 4 years because of COVID. So we weren't quite sure what we'd find, but fortunately he's in pretty good shape. This is just another view. This is looking at the center of Haughton Crater. So you can see it's been there so long. 23 million years is a fair amount of time, even geological time. So there's a lot of hummocks and hills and valleys and erosion going on. But if you pull back and do an aerial shot, you can really get a sense of this enormous impact crater that tore the heck out of the landscape 23 million years ago. As a result of that impact, a lot of ejecta was thrown up. So this is one of the medium-sized chunks of rock that was dug up out of the ground and tossed, I think, about 4 miles from ground zero. So you get a sense of how powerful this impact was. This is the second obligatory shot of us standing at the highest point next to the crater, trying my best to look heroic there. On the way back, we went through an area that they call Planet of the Apes Valley because it looks so much like the Forbidden Zone. and we stopped. That's Pascal down in the lower center, taking pond samples because they're trying to see if they can find tardigrades there. Because as you know, tardigrades or water bears are very robust little critters. They can survive drying up for hundreds of thousands of years, and then you wet them and they come back to life. So there's a thought that maybe we can learn something about hardening human beings for radiation and so forth by studying tardigrades. You can hit them if once they're inert, you can hit them with gamma rays and they still come back to life. So he was down there collecting tardigrade samples that we brought back for evaluation. We spent a lot of time on days like this. This is high fog. We also had low ground fog. It doesn't shut down the day, but it does mean that if you're waiting for a flight to come in and get you, you're going to wait longer. And in fact, we did have about a 4-day delay coming back. This is just more fog. That's a fog bank rolling in. Once it arrived, of course, you can only see about 30 feet. The weather's really highly dynamic there. So you can have bright blue bowl of sky over your head 1 minute, and then within about 15 minutes, you can be fogged in or clouded over. Didn't get a lot of rain, a little bit, but mostly it's fog and cloud cover. This was our second traverse. There was, I think, 7 of us. We were heading out to about 28 miles away one way. In the previous season in 2018, they had been trying to blaze a trail down to the coast where ultimately NASA is going to deliver a higher fidelity pressurized rover mock-up that doesn't look like a Humvee. It'll look like a Mars rover. But they took a Humvee and a bunch of ATVs down there. One of the ATVs had to be left behind because they ended up evacuating halfway back to camp in a hurry. And the Humvee was actually left halfway down to the coast. But you're in an uninhabited island, right? So it's not like you have to go back and park them at base. Nobody's going to steal your hubcaps or your steering wheel out there because there are no people. So they left those 2 things there. And we decided we needed to go out and see if they were okay and try and retrieve the ATV. So we crossed about 28 miles of this kind of terrain. The balloon there was for one of the 2 primary exploration projects that we had in this particular trip. The idea is to mount a 360-degree camera under the balloon, set it up a couple hundred feet, and then rather than having to use all the power and difficult technology it takes to fly a helicopter on Mars to scout ahead, you simply put a balloon up, and the wind in Mars is so thin, they don't get deflected very much. So we were just testing if you could winch a balloon up with a camera on it and check out what's ahead of you to see if you've got a good area to traverse either for robotic rovers or people. So about 16 miles into this trek, we found the poor little green Kawasaki ATV that had been sitting there for 5 years. The high water mark was up right to the base of the handlebars. It had spent at least 3 of those seasons completely submerged in an Arctic river. So it had gotten very wet, and we thought, well, that's probably that. But lo and behold, we charged the battery, put a little fresh gas, things started up right away. And when I got back, sent a very nice letter to Kawasaki saying, your products are awesome. So we took it back with us, and it ended up being the most reliable ATV we had. Here's the Humvee, about another 10 miles up the road. It used to be red. Now it's pink because it's been sitting in the Arctic sun for so long. And we weren't going to bring that back on this deployment. We were just checking to see what kind of shape it was in. It was doing pretty well, except one of the doors on the edge was peeled back about 3 inches. The metal was actually bent out. And that's the power of polar bear claws. And we can see the polar bear tracks and some scat nearby. So they do get curious and they have a lot of power. So I'm very glad we didn't meet any. That's what the Humvee looked like when they got it. And they were using these tractor wheels to see how it would work on difficult terrain. It was kind of a mixed success, but it is functional. As I said, in the evenings, we tended to have science talks. That's John Scott over to the left. Very soft-spoken guy, but as it turns out, he summited 3 of the highest mountains in the world. I already told you about his polar experiences, and he's got a lot of hair-raising things to say about sleeping in a sleeping bag on a blanket that's basically suspended over 10,000 feet of altitude in the thin air. And I mean, just hearing it made my stomach clench a bit. But just a remarkable guy. And this is a great way to entertain yourselves when you don't have any outside communication. The rest of the time, you just spend working at the ops tent. We did have a satellite phone for emergencies. As it turns out, the iridium phones that are so lauded, at least up this high in elevation, 15 or in latitude 15 degrees from the North Pole, you can't have more than about a 3-minute conversation before you lose your satellite. We also had Inmarsat box, which is supposed to give you broadband, but it only worked for about an hour a day and cost, hold your seats, $7 per megabyte. And when you're checking your Google email, it takes about 30 megabytes just to handshake. So as you can imagine, we basically just didn't talk to anybody while we were there. The other primary project for exploration and resource gathering was to be flown by drone. So we fitted up Gabriel in this Hamilton Strand spacesuit mock-up. And the helmet's not on right now, but you can see how it's laid out. The backpack is square and high like that because in this particular design, rather than going in and out of your habitat or in and out of your pressurized rover in your spacesuit, a door swings open in the back and you simply walk backwards and snug up to an airlock and you crawl out of the suit and leave it behind. So it takes a little bit of calisthenic ability to do it, but it keeps you from having to worry about dust abatement and all the problems you have with that. Don't forget, Martian dust, real Martian dust, is toxic. It's laced with perchlorates, and you really don't want to have very much of it airborne inside your habitat. So this is one of the systems they were exploring. So in this particular case, we were experimenting with how you might control a drone with a spacesuit. The glove in this case is padded up to simulate what it's like to have your spacesuit pressurized. Because if you know much about Apollo, those, even at 5 pounds of pressure per square inch, those suits got rock hard. The gloves were really hard on their hands. So two of the things that Pascal's been experimenting with is simplified manual controllers and also gloves with sensors in them, so you simply control the drone by hand gestures. In this case, we were experimenting with a handheld unit. So we were both, in this particular test, we were both testing flying the drone,
a little higher,
getting a look over the horizon. Sorry, that's me being a director of the background. Getting a look over the horizon towards the next geological target, and then actually flying up to it, extending a little adhesive pad and sampling the soil and the grit with that pad. So instead of driving your rover over there across possibly dangerous territory, you're doing it all by drone. So that was successful. The last big experiment was from MIT's Haystack Observatory. Here's the 3 guys from MIT. And this experiment is to try and get the very, very weak signal from the formation of the first stars. So there's a period about, I think, 100 million years after the Big Bang or so, when the universe, it was just empty, and then it reionized, and that's when the first stars started to form. So that reionization signature is still coming to Earth, of course, because it's very far away. But it's very weak, so you have to go to a place that's radio silent in FM. So you either go down to the South Pole or you go to the North Pole. So these guys set up an experiment to do just that. They had to lay out 6 miles of wire as a backplane to insulate the antenna from ground reflection. So they are putting down tent pegs to get their line straight. And then they strung this wire. So if you can see the color there, it's a little blue right towards the antenna in the center, and then it gets pinkish red as you move out from that. This is that 6 miles of wire, which those poor guys strolled back and forth and laid down manually. And each strand had to be the exactly right measurement away from the next one. So close to the antenna, they're maybe a 1/4 inch away. As you get further out, they might be 2 or 3 inches away. Incredibly exacting work. They were real Spartans. They set it up in about 2 days, and then we started running the experiment. We did discover a few things pretty quickly. One was we had some interference. It didn't seem to be coming from any electronics we had because we shut everything down. So it appeared to be from the environment or from the sky. The other problem is, of course, it gets very cold up there. The temperatures with wind chill range from about a low of 20 up to about 38. So you had to keep the instrument in the center, the antenna, heated. So these poor guys had to ride out there about 2 miles from camp 3 times a day to change batteries to try and keep it heated, because they didn't have big enough solar panels, and solar panels cause radio interference, batteries don't. So this was their life, driving out there 3 times a day in rain and sleet and mud and no snow, fortunately. Sometimes intense fog. And of course, every time a person goes out to change a battery, somebody else has got to be doing polar bear overwatch with the shotgun. We did have time for a little bit of fun. The MIT guys are golfers. They decided that they wanted to have a golf tournament while they were out there. It's not ideal putting green territory, but they did manage a couple of holes and won. I think just by sheer luck.
Wow.
So we called it the Devon Island Country Club, and I'll let you figure out what that acronym means. So after we had been there for 3.5 weeks, we were ready to go. There was a big storm front moving in. We wanted to beat it out. Unfortunately, Resolute Bay got fogged in before we had a chance to go. You have to call a few days in advance to get on the schedule because these are all chartered flights. And the charter operator said, sorry, we're fogged in. You got to wait it out. Fortunately, the storm, for the most part, missed us. So it gave us 4 more days to run the radio astronomy experiment. So in the end, it was actually not a bad thing. But we spent a lot of time looking at this. And when it gets that cold and that damp, you go inside your tent or climb in your sleeping bag and wish you were somewhere else. I took about 3,000 images. Mainly, I just wanted to give people a sense of what the environment was like and what the camp was like. The airfield's over to the right. There's another airstrip over the left, running perpendicular to the one they use for the most part on the right. And the little tent with the orange stripes on it down front is where we did our bodily function business. Again, 2-hour sunsets, 2-hour sunrises. I can't express to you how breathtakingly beautiful it was. I took a lot of photos to try and capture it, but you just have to be there. Again, none of these are color corrected. This is just what it looked like. And you take a time lapse of this, and it's really like stepping inside a Nat Maxfield Parish painting. It's just amazing. Down in the foreground there is the greenhouse where they did their year-long autonomous greenhouse experiment. Another picture of the same angle. I was the only person that did it, but there's a couple of times where I stayed up all night. I knew it would pay for it the next day, but how often do you get to see sunsets that go throughout a whole evening? One more obligatory picture of me looking studly, carrying my tripod and freezing. This is one of the time lapses I took. This one's a little soft, but it does give you an idea of the dynamic weather. Obviously, this is compressed as a frame every 15 seconds. But if you sit out and watch, this is the kind of evening you have. And it was really incredibly magical. And as cold and as harsh as it was, I'm looking forward to going back. Same time-lapse settings, just slower moving clouds. So before we left, the last thing we had to do was close down and winterize the camp. The environment's very tough on all the structures and the machines. So everything has to be packed away. All the ATVs are rolled into one of the structures and parked. Everything's sealed up as best you can. The big enemy there, besides the grit, is black mold. Any surface that gets damp will grow black mold, and everything gets damp because in the winter it gets cold and very wet in the air, and all that condenses inside these structures. So the only way to avoid that is get a mop, cover it in bleach, and wash everything down in bleach, and then step away from it so you're not breathing bleach fumes. So that was our final step. We went out in 2 legs. The first group got the first flight. There was 4 of them. It was the MIT guys plus 1 more. So here's the Otter coming in to retrieve us. This is Ken Boric Air. They operate all over the world in the harshest environments and the weirdest places, and the Arctic is one of them. It's expensive, but you got to be able to get in and out, so that's what we did. So the first group was taking primarily, sorry about the sound, it's really loud, but I want you to see the cargo they had. So the first group was taking out the radio astronomy experiment, which is packed in those cases and about 18 more. So the front half of the cabin was filled with their experiment, and the back half was filled with 4 of them. We had to wait about 4 more hours for our flight, and lucky us, the last 4 of us got to go out with all the garbage and the mini bags full of human waste in front of us in the cockpit. So they were triple bagged. We didn't have any accidents, but it was an odd feeling to be sitting behind a mountain of you-know-what. This was our first stop flying out. This is an Arctic Bay. Again, it was 4 days getting home. We did have a little more time on the way back, so we were able to tour a couple of these areas. And as I said, they're very rustic, very basic frontier kind of towns, all prefab buildings. This is really life on the edge and everything. There's no roads or railroads coming, of course. So you get some stuff by ship, but the important stuff is flown in. So just an example of what things cost. In our first night's accommodation, once we got back to Resolute Bay, we were in a dormitory that has 4 bunks to a room, and each bunk cost $350 per night. The room is $1,400. So that's just what it costs to bring in, you know, fuel to heat the water, to wash the sheets and cook the food and all that kind of thing. So it's an expensive undertaking. Just before we left, we were grabbed by somebody just before we left for the airport saying, hey, would you come talk to our kids at day camp about your experience? So I kind of groaned because I knew we had a lot to do, but Pascal, being the ever ready STEM guy, said, of course. So we crammed our schedule by running over to this prefab building where there are about 30 kids, none of whom were wearing masks. We were still a super spreader event, if you ask me. 2 of the guys gave fairly technical talks, which kind of went over the kids' heads, and I tried to talk to them about more basic stuff. But it was a good session, and that was our last nod to Resolute Bay. So our 8 stops coming back. The last one we had together was in Ottawa. This is 2 of the MIT guys and Pascal with Apollo the Wonder Dog saying ta-ta. And the next thing I knew, I was back home trying to figure out where I was going to put all this junk for the next year until I go back. And that's the gang, who are all now new friends. It was a good bonding experience, and I'm looking forward to another one. And just a quick review of our achievements. We repaired and reopened the camp after a 4-year abandonment. Got the ATVs running again, made sure that they'd be good for next season, rescued the stranded one, tested drone exploration and sampling system techniques, tested the balloon reconnaissance techniques, gathered stream and pond samples. The second traverse on the way back, we went through an area that had not been traversed before that we know of anyway. It might have been in primitive times, but certainly not modern times, and found a couple of new routes back to camp. And then, of course, I shot my brains out in terms of photograph and video. And if you're interested, there's a series of dispatches on space.com. I wrote 14 episodes of it, and I could put that link in the chat if anybody's interested.